It's my job to throw spit wads at the interview.
Yeah,
Okay.
I could duck. I got a little blockade here. So yeah, with this, I'll just roll the entire time.
Okay.
I'm not going to cut or anything, and you can talk directly to me. I know, try to ignore the camera. That's a little tough, but you know, if you need to stop at any time or consult each other and say, you know, hold on, we're going to talk about this, or make a plan of attack. Sometimes, you know, you guys have the same thoughts that you want to sort of go over.
We have a signal too when we have the same thought. We go.
Yeah.
And we hear,
Yeah.
it's terrible. We hear, I'll say, Mr. Doetch, remember to do this. And he'll go, that's exactly what I was just thinking.
That's our code for we're not thinking the same thing.
Yep.
We're really good about that. So again,
Yep.
we'll just both do it at the same time.
Got it. So if we talk on top of each other, that's
Finishing
why.
Each other sounds very
Yeah.
fun.
I did call him honey yesterday on accident.
Now you're on film saying that.
Oh, well, okay, there you go. Edit that.
Yeah, this will all be all edited out, so no
Okay.
worries. All right, so actually, the only time I'm gonna have you look in the cameras now, and I'm just gonna have you guys introduce yourselves. Tell us what grade you just taught and what school we're at.
Okay.
Hi, this is my team partner Tammy Falk, and we're both first grade teachers at Alice Taylor.
And this is my team partner, Mr. Doetch.
Very good, very good. All right.
Did we get first grade?
I said my first grade teacher at Alice Taylor.
Okay.
All right, so the first section here. We want to understand the decisions you made in planning for this lesson and how it fits into the unit and year. So how does this lesson connect to and build on students' prior skills and knowledge? What was taught before this lesson and what will come after it?
So we focused our year on, what we've done is we've actually built a continuum and a progression of all the standards and all the mathematics through the entire year then. And this just happens to fall in our Unit 6 in it. So we actually took a former program and we did a page-by-page analysis of the program, and we looked at how does it actually tie into the Common Core. And then if we thought it was actually tying in it, we actually included that part in our progression. But then if a part was not a strong part of the core, we actually looked as a team then, how can we change it and modify it to the core? And so, basically our beginning of the year, it started with looking at conceptual understanding then, and being very familiar with sums and numbers, conceptually wise, to sums of 5. And then we took those numbers and said, now how do we represent those numbers into a model then? And then we've taken those numbers and progressed them into what does it look like on the abstract side. And so we use a term that we use that, you want to tell them that?
We work on a conceptual understanding first, so you'll see a lot of manipulatives with the students. A lot of the students have gone beyond the manipulatives. They can use the representation piece of it. During the lesson, you'll see a group of children that are still using the conceptual, the manipulative part of it. This lesson, this overarching theme of this unit is looking at fact power, putting numbers together. We're trying to work on a fluency, but at this point they still need to use strategies and have that option of manipulatives. They're looking for that fluency to build so that it's automatic back into second grade.
And then one thing we've looked at too then is making sure that throughout the entire year is that all of the standards in every lesson that they're working with connects to an overarching theme and to an overarching concept. And one great example is in our Unit 2. On Monday, we teach the students how to use the number grid. And then on Tuesday, we teach them the number line. And then Wednesday, we're teaching the students how to use pennies. And then on Thursday, we're teaching them how to use clocks. And then on Friday, we do nickels. And in the past, and one thing that we've always done is that we've always taught those in isolation. But looking at putting it all together, now we've learned that these are all connecting themes and they're all connecting math ideas. So now we teach the kids on Monday, here's the number grid, but what are we using the number grid for? We're using it for numbers and patterning. And then on Tuesday, we say, great, here's the number line. Where have we seen by counting by ones before? Where have we seen that connection? And the kids go, oh, well, we saw that on Monday using the number grid. And then on Wednesday, we teach pennies. Pennies is another tool we use to count. So kids, where have we seen counting by ones before? And they have those connections. Well, we saw that on Monday. We saw that on Tuesday. So those who don't understand counting by ones, here's another real-world tool to use. And then on Wednesday, we do the clocks in. Well, how do clocks count? Clocks count by ones, units of 1, and unit by 5s. Where else have we seen in the week counting by 1s and 5s? On the number grid and on the number line. And then in Friday, when we get to the actual nickels then, well, where have we seen counting by 5s before? What other systems use counting by 5s? The number line, the number grid, and we saw it with coins then, and we saw it on the clocks. So we try to make sure that our lessons are always connecting back to the major overarching theme, and that's been our progression of our lessons in. So they know what they're doing, and that what we're doing today will follow with what they're doing tomorrow. And that way there's always that connection piece. Is that good, Lynn?
I don't know if we got what we got it.
Yeah, I wanna sneak over there and get my phone and record a little.
Yeah.
Okay.
So I can shoot off to Amanda.
Okay. Good answer, by the way.
And I flubbed like 5 times, but okay.
We didn't notice it.
Good. Edit those out.
Don't overthink it, Tim.
Okay.
Yeah.
You're doing awesome.
Oh, yeah.
You're doing
Well,
awesome.
thank you. Good,
You're
good job,
welcome.
Mr. Doetch.
Okay.
Good job.
All right, so let's talk about the clusters or cluster targeted in this lesson. What did you do to make the lesson reflect the full intent of that standard or cluster?
Did you forget something?
Yes, the clusters.
The clusters.
We have the clusters.
And I flipped that question. Let's talk about the standards or clusters targeted in this
Okay.
lesson.
So standards we were looking at were 10A6 and 10A7. And we're looking at adding and subtracting within 20, understanding the addition sign, and then determining if, when you use the addition sign, if that number sentence was true. Then we also we used out the pan balance for that conceptual part of it.
So we started with looking at the fact tables in it. What addition and subtraction facts do the students already know based upon earlier lessons in? Because in units 1 through 5, then we spent a lot of time on building fluency with strategies and understanding, and then building conceptual understanding through the students' problem solving and generating their ideas. And so this was actually the second lesson in the unit, which was looking at equivalent names so that they start to develop the fact power. That way when they hear someone say a number model or an expression, they're able to compose that into another one with the same fact power. And then by the end of the unit then, they're going to be able to have,
We need to look at that fluency again in the fact family so that they can look at 3 add 4 equals 7 and know that that's the same as 4 add 3 equals 7, 7 equals 3 add 4, and then we're going to add in the subtraction piece in the next lesson.
and so we're spending a lot of time in this unit then, spending a lot on the conceptual side. And then when we get to about units 4 or 6 or 7 around there, that's when we're going to start on the representational side. So then at the end of the unit, they'll have the abstract side so that when they see the number models or the facts, they can put them down rapidly. Because the whole goal in first grade then is to get conceptual understanding. They have the procedures and they have the skills to do it, but they're able to do it with strategies and they understand what they're doing. Because the ultimate goal then by the end of first grade is that when they go into second grade is to work on.
They work on the fact recall, automaticity of it. And we really focus on that conceptual piece where the kids are able to do it orally, to do it with pictures, to do it with manipulatives, to do it written, and then using real world situations. So we try and incorporate all those in the lesson so that they have all those different ways to express the mathematics they're thinking.
All right.
I don't even know if that answered.
That was totally awesome. Okay.
Which of the core action indicators do you think this lesson best exemplified? And how did you plan for this?
Now, do you want the indicators or the core actions themselves in? Because we went through all of them just real quick.
Mhm.
You want the indicators?
I mean, you don't have to break
Okay.
them down bit
Don't
by
have to give
bit,
a
but-
report.
Okay.
Okay.
Well, I'm going to model them over.
Okay. We, in looking at the core actions, using that connecting to the standards, really looking at that shift from giving the students a math problem and saying, here's a way to solve it. We really want to work on getting them to solve it themselves and then share that, how they solved it. So then those strategies they come up with on their own, and then someone else can try it rather than us saying, here's the right way. So we wanted to make sure that we look at the standards and give them the opportunity to struggle through those problems and really create strong strategies.
And then in core action too, the indicators A, B, and C were really strong for us, is that we've learned to use the students' reasoning and the students' understanding then to guide the lesson. And we've actually have them showing us their understanding then. So when they give us an answer, well, how do you know? But then can you prove that to us as well? And we had a couple times during our lesson then where students had a misunderstanding, but they used students' explanations and the reasoning of others then to formulate their own answers and then to correct. And then one model we use quite a bit too is the students discuss their answers and they're able to talk with a partner, but then their partner responds and if they agree or disagree, but then they have to tell them through an explanation of why they agree or why they disagree.
And that's been a huge shift for us, is that not just what is the answer, but how did you get the answer? So as we've worked with the standards and really connecting to them, it seems more important for them to come up with that strategy, that explanation. How did you know, that proof or evidence, as some of them have called it? How did you get that answer rather than the answer is 7?
And then to make sure that we've engaged all the learners in here then too, we've used a strategy called revoicing. And that requires all the students to pay attention to what they're doing then. So when a student gives an answer then, we choose another student based on our app called Stick Picks, and then that student then just, whoever it's going to be has to revoice what the first student have said. So they've heard an explanation, now they've heard it revoiced, and then the third student then has to say, is that exactly what they said then? So now everyone's listening to the lesson, they're engaging into the lesson then, and we're hitting all of our learners then.
And that's a stretch for first graders. That's something we're still working on a daily basis, that revoicing. A lot of times they're ready to tell you what they're thinking rather than revoicing what another student said.
And then in core action 3 then, our indicators that were really strong were the first one, A, using strategies to persevere when solving the problem. And that's something that has to be established at the beginning of the school year. You can't just have students persevere and say, oh, you didn't get it right, what do we do? From day one, we've always told our students, you know what, that answer didn't make sense, or that strategy didn't solve the problem, so what do you do? And our students always tell us back, well, we just try another strategy then. And they learn too, well, if that strategy doesn't work, then what do you do? Then they say, well, I try another one. So they've learned that it's not that I got the answer wrong. It's what did I learn from the mistake of the answer, and how do I go about attacking it again, which is using another strategy then.
And for us, we have a benefit of having at our school, we spend a lot of time looking at the core actions, and then we're actually observed for those to say, which did you use? So we've had an opportunity to go through these as a staff through professional development.
And we've really embedded the math practices too, right into the core action 3, where students are attending to precision, they're persevering through the problem, they're using their models appropriately, and they're using their tools strategically then. And then the students are listening and critiquing the reasoning of others in, and then they're formulating their own ideas. And so we've taken the math practices, and when we use the core indicators then, the part that we've really worked on then is making sure all the students have a voice and that all the students are conversing with each other, versus as our old model before the Common Core, which was we'd be up here explaining everything and then having them revoice what we said. The new model is the students are showing their explanations and showing their understanding. We're just facilitating those deeper questions for students so that they're able to do the mathematics and understand what they're doing then.
And we have to admit, we looked at the Common Core when it came out as first grade teachers and said, this is impossible. First graders cannot do this. They cannot explain their thinking. They can't apply strategies without us showing them what to do. And so we have to go back and eat those words because we changed our expectations of the students. We set the standards as the minimum that we wanted all of our students to reach, and we taught differently. And as soon as we were able to raise those expectations and teach them the strategies to solve these problems on their own, they met those expectations. And we were wrong.
And that's on the core action 3, the indicator 3F. That was a huge one for us because when we first started teaching together, we'd ask students, which one's the circle, which one's the square, and the kids were able to identify those. But then when the core came out, we came back and said, well, how do you know which one's a circle? How do you know which one's a square? And the answer every student told us was, which one's the circle? And the students always said,
I just know it's a circle. My brain just told me.
And that was a huge eye-opener for us. That was, we really have to make sure the students are understanding why this is a circle, what is the attribute of it, or how do I compose shapes to make a new one? And that came to numbers then too. We'd say, kids, what is 5 and 5? And they'd shout out 10. And we'd always get that answer back, well, how do you know it's 10? Well, I just knew. Or the answer just is. So we really unpacked that and going, well, show us through the tools then how you know, which is going back to the conceptual side, making sure the conceptual side is very strong. So that when we take those away, then they can represent those. Then when they can't represent it, then they go to the abstract. And so that way when they see the abstract, they just scaffold it backwards. If I don't know how to do this in the abstract, I go back to the representational. If I don't know how to represent it, I go back to the concrete. And then they work forward with it then. So that's what we're spending a lot of time in the indicators, making sure that conceptual is strong. Then we show them the representational, how to represent it. If we don't have the tools, then I can solve the abstract then. And it's amazing because we're seeing things that we've never seen first graders do before. And we look back on our instructions. We've been working together for 4 years now. What we were doing 4 years ago is not what we're doing today. It's a complete change in our pedagogy, but the results are we're seeing incredible things happening, and I never ever thought I'd see first graders what I'm seeing today.
All right, excellent.
Longest answer ever.
Cut that out.
You like good information. All right, so we're on to section 2 here,
Okay.
talking about the shifts. We are interested in how the shifts required by the CCSS are being incorporated into your classroom. So discuss how this lesson illustrates the shifts required by the CCSS.
Okay, got my notes on that one too. I was on a green paper.
Your green paper.
The green paper are the
Gotcha.
shifts. Really
Okay.
do. And then the shifts, then core action shifts. So These are the shifts here.
Methodology.
Remember, the
Yeah.
focus, the
Gotcha.
coherence, the rigor.
Okay.
Okay.
So the focus of our lesson is on the standard. That's where we start with everything. We have a math program that we use, but we've taken that math program and made sure that the pieces that we're using are connected to the core. That was step one, because you can't take an existing program and just say, well, Common Core is right here and right here. You really have to dive into that if you're going to use that program and make sure it is aligned to the core.
And then with the focus then too was that the first shift was making sure that was a really strong focus. And we actually met some of the authors of the Common Core, and they told us, you know, when you're teaching the Common Core, just remember, Common Core is not the maximum expectation of learning, it's the minimum level. And when we first heard that, we kept thinking, oh my gosh, I'm going to kindergarten. There's no way students can do this, and this is going to be the minimum expectation. But then now we've seen in our own classroom, and by implementing the shifts and implementing the core, the students are always hitting the maximum. And now we call that the minimum expectation. And we're clearly seeing that this is the minimum expectation by just connecting to the core then and having the students a part of the learning then. And so with our focus on strongly where the standards are focusing then, we're clearly identifying, okay, throughout the year, let's work on this part of the standard. Now let's incorporate the next part. So we worked on for instance, operational algebraic thinking. We started on sums of 5. Then we went to sums of 10, and then sums to 15, and then sums to 20. But we've noticed in the last couple of years, though, that once they're at sums of 20, they can go beyond sums of 20 all the way up to 100 then, just by making just a couple changes into the instruction then.
And as the Common Core has been in place, we can see that we're not having to spend as much time on those numbers 0 to 5, because that's really strong coming up from kindergarten for almost all of the students. We can hit that really quickly as a review, go on to the sums to 20, and then again, like Mr. Doetch was saying, easily go on. The kids want, give me the next step, so we can look at those second grade standards and know we can go a little bit further, and then occasionally we get those groups where we have to do that enrichment with and look at some of the third grade standards, and looking at the standards don't the standards don't limit what we teach, but they guide it.
And then the second shift, which is the coherence then, we're thinking across the grade levels. So we know that our kindergarten teachers here, it's incredible because there's foundational skills and the conceptual side and the procedural sides of 1 to 5 and 5 to 20, or excuse me, 1 to 5 and 5 to 10 are extremely strong. We just take those resources and their manipulatives they've used, and now we are extending them to 20, and then we're taking them into numbers in base 10, and we're extending to 100. And then what's great is that when they go into second grade, they're using the same strategies that they've developed in first, and they're extending their knowledge and saying, well, it's the same skills, but now I'm doing it from 100 up to 1,000. So the continuum goes right through, and it's all connected from kindergarten all the way up then. So if the skills are strong in our first grade, we know for a fact through our data we have at our school here, the students who scored really well, which ended up being all of them, when they went to second grade, the scores continued to grow.
When we look at the lesson that we planned for today with the equivalent numbers, we're building on that fact power. We're building on them knowing 3 add 4 and 4 add 3 both have a sum of 7. Then when they get to second grade again and they have to have that fact recall, they've got the building block of it by understanding those equivalent names. And so they're not feeling like each fact is a separate thing I have to know. I know this group and I know this group. So we're starting now to get them to that fact recall for the second grade standard.
And then when we think of the third shift, which is the rigor then, making sure that all students are being rigorous. And when we first heard the word rigor, we thought it's a monster with teeth, but we realized that rigor just means we're just truly getting all kids to understand the Common Core. And so we've got, different students in here, and we've got some groups that were able to compose and decompose numbers then and show equivalent names with 2 sets of numbers. Our goal then is by the end of the unit then that they can use 3 digits or 4 digits. So I can say that 2 add 3 add 4 is an equivalent name for another number then. And so it's going to take a little bit of work then again with the conceptual side. Those kids who are ready for 2 digits, we're going to get them into 3 digits. Those we saw a couple today then that had 3 digits then, and our goal then for them is to work in numbers beyond 20 then.
Beautiful. This is a little question about what happened before the CCSS. How did you teach the content of this lesson prior to the CCSS? What is the same and what is different?
I have apology letters
I
that I
know.
go back and write to my
So
students
embarrassed.
because I remember clearly teaching to the students then, and I was really good about differentiation because there'd be a problem up on the board and I'd say, kids, here are 3 and 4 different ways to problem solve it. Now I want you to go back and practice those strategies.
Yeah, practice
So,
my strategy, because I know everything and you have to learn how to do what I do. So looking back, we have a stack of apology letters. As far as the fact power, we had flashcards in first grade. Shame. We had flashcards. That's how we taught that. And we couldn't figure out when we had kids who progressed through the years, they got to multiplication, they started memorizing their multiplication facts. And the teachers would say, you didn't teach them addition and subtraction. They don't know those facts. Well, they never had a concrete understanding of the number 7 and how many different ways you can come up with 7. Then they just start trying to multiply it, and all the pieces fell apart. So that it wasn't long-term learning.
And we were really bad about jumping to the abstract. We would put up a number model or expression on the board, and we'd say, solve this, or we'd say, here's a strategy to do it now. You need to repeat what I've shown you. Or I'm going to show you a second way. In fact, I was so good, and we were so good at differentiation. Here's a third strategy on the board. But then we'd ask the kids well, how come you're not problem solving, or how come you can't apply this to another situation? And they'd look at us saying, well, I don't understand it.
You didn't tell me what to do.
And so what a big shift with us has been now is that, when they get to a problem that they don't know, we ask them, what strategy could you use to figure it out? And if they work through one and they have a strategy that works, then we say, great, can you apply that strategy to another problem type? And if a kid gets to a strategy that it doesn't work, we say, well, what do you do about it then? And they say, well, I just try another strategy then. And they're creating and using the manipulatives with the conceptual, they're generating their own strategies then. And the great part is they're teaching one another. Those kid conversations that they have with one another of how they problem solve are just so much better than the teacher being at the board and saying, here's the problem, now here's you solve it. And we realize we're engaging more learners and all of our learners when they revoice and they're sharing their strategy with each other. So, it kind of makes our job a little easier too, because we're not setting all the lessons and showing them what to do. We're just coming up with the questions, and we're scaffolding their thinking and what the students are doing then.
I think one of the biggest pieces is we used to teach the program that the district provided with some supplements rather than looking at the standard. And we had very skill-based standards at the time, so we taught them skills rather than concepts.
All right. So,
Yeah, it's so sad that we don't have an answer to these questions.
We haven't thought of these or anything.
We haven't thought of them or...
So,
all right, we're on the third section here.
Okay.
Student engagement is critical to the work of the CCSS. We want to understand how you ensured that all students had the opportunity to productively engage in the work of the lesson. So how did students handle this lesson? Did they understand the mathematics of this lesson, and how do you know?
I have to process that one more time.
Okay. Well, trying to get in a full lesson so that we could get that for everyone to see, we extended their pocket power a little bit today. So we did see some instances where we had some students who weren't as engaged, but as soon as we let them choose their tools, then they were more engaged. So having those manipulatives help.
You're going. You want to say that? Started that again?
Yeah. No, okay. I don't want to start that again.
Hey, we're on. Do that again.
Okay. So, how did our students handle this lesson? We extended our math time today to get a full lesson, so we could film that today. So we found some of our students lost a little bit of their pocket power, so we did have to give them some physical reminders throughout the day. But once we were able to give them some tools to work with, for the most part, they chose the tool that was most appropriate for them and were engaged in coming up with that answer. And they knew through the app that we use, through Stick Pick, they're going to be called on. And so we build in some opportunities for them to talk to a neighbor if maybe they've missed a piece of the direction. So we try and get them back engaged by that. Everybody's accountable to one person and then accountable to the whole class. We work on the revoicing strategy that helps with their engagement. And then we have, I'm lost on that one. I lost it again. Okay, just pick up where I left off.
Take a deep breath.
Pick up where I left off.
So one thing we do too to help engage our students in is we really work on building understanding with the conceptual side, using the tools and resources that are considered appropriate in first grade. And we had to start with smaller numbers then. So we did start off with the Unifix cubes, where students had Unifix cubes and they were composing and decomposing sums to 10 then, showing us different ways. Then we gave them another tool, which is the Rec and Rec, where students were able to change and manipulate numbers using a Rec and Rec system. Then we went into the base 10 blocks, where students were composing and decomposing then using the base 10 blocks. And then we've incorporated number grids and we've incorporated other tools then. But the students know that they have a tool that they use then, developing their number sense and their fact power. And they're very familiar with those. So when we start extending those into numbers beyond 10 into 20 and then 20 into greater numbers then, they have a tool they're very familiar with then, because that's how they've generated their previous answers before. But then what we do then is we have students sharing and talking and conversing about, well, I use this tool, here's how I developed my understanding. one student may say, well, I use the Unifix cubes, here's how I developed my understanding. And that bridges for those students and more connections in, saying, oh, well, I understand what you're saying there. If you use the Unifix cubes, all I had to do was make it a friendlier number and add one more. Or I took the Unifix cubes and I added them and I just counted on then. They're seeing, oh, more multiple tools and tools that are appropriate for my learning then allow us to use those. And that's one of the biggest things that's changed as well in our learning in first grade is actually letting the students use manipulatives. And I was really bad about, I had a wall of manipulatives and those would just sit there. But now I've learned to use them. And every lesson then in first grade, it's a manipulative base then, where they build their constructional understanding. That way they can represent it. So when they see the abstract, then they know exactly what it is to problem solve and how to scaffold it backwards and into their thinking then. Another thing we've done too with student engagement then is the students know that we're just going to randomly call them. So we use an app called Stick Picks where it has all the students' names on it, and it just randomly picks a student, so they know that we're just going to randomly call in a student. But then we also have a student revoice it then, and we just randomly pick a student to revoice their understanding. So they're aware that they have to be paying attention because I may get called on to revoice this, or I may be called on this to share my thinking understanding, and they don't know who's going to be called, and we don't know who's going to be called. So in having that built from the beginning of the school year with procedures then and with our routines has really helped out the Common Core. They know the routine, how to get materials out. They know the routine and how to share their information. They know the routines and how to agree or disagree. And that's things we had to teach to them, but because those are in place then, we can run any math concept with the students then, and we're always getting high levels of engagement and we're getting high levels of conversations.
Moving on to how we know. We had an assessment piece built in the independent books when they were working independently. They had to come up with equivalent names for 11. And you saw Mr. Doetch going around with the clipboard, looking at the students, asking him specifically, how do you know, which equivalent names did you come up with? When I was working with my group at the table, they were able to come up with equivalent names. I have one student who has moved into independent, doesn't need that support, but they were able to come up with equivalent names with support. So that's a notation that I made and which math tool they were using. Some of them were using a math tool and it wasn't working for them. So we made notations, what's working, what's not working. But we looked at those equivalent names in their math boxes to see if they had that concept of how many different ways can you make 11.
And so the kids in that, as I was walking around that were struggling with the actual concept of equivalent names then, every single one of those kids went straight to the abstract because they were trying to write number models and expressions of the number. And all I had to do with those students was to say, can you show me what an equivalent name is using the blocks in, which is the conceptual side. And as soon as they had the blocks in, or they had whatever tool they're using, they were able to go back then and say, oh, well, an equivalent name was 8 add 3, or an equivalent name was 5 add 6. Then they transferred it into the abstract, which was the number model, or into the expression. And then all I had to do on my clipboard was I just put a check or minus. Plus, they understood this. Minus, they just needed extra support, and I just had to scaffold or ask them questions to get them back onto the task. And then when I did my final round then, it was great because every single student had understanding and every student was able to write equivalent names in for the number.
And even in my group, with one exception, they were able to come up with 3 names and then show me how they knew that that was an equivalent name for 11 using one of the tools.
All right.
We kind of covered differentiation in that one. I mean, I don't know if you, did we
Yeah.
cover that?
I think so.
Yeah, we got 42 kids in here, we're right down to every little kid and where they were.
Yeah.
Do you want their map scores? Because we have a graph.
I can tell you
And what their
every
areas.
number model they said too, that
Yeah.
was equivalent or not. We wrote it all down, so.
See, they eased us in with 37 kids, then 39 kids, then 43. So,
Yeah, we've learned too that, gosh, we would take 50 kids because it's just the same thing with all of them. So, that's one thing we've learned too is that the class sizes, it doesn't impact really what our students learning do. It's the engagement piece, it's the conversations, and it's how we're connecting to the core. That's what's impacting student learning then.
You guys
talked off camera.
Sorry. Wait, go sit over there.
I was trying to like,
Sorry.
Yeah.
say it over there.
I can say it again.
No, you forgot.
Did you guys talk about Core Action 3 at all? We're actually curious about which behaviors from Core Action 3 did the students best exemplify in this lesson?
These are the malpractices.
Oh. Well, tick them off. Attending to precision. So the kids were They knew
persevering, and-
persevering.
So for number, we'll start that again. So math practice 1, which is persevering and problem solving.
They were able to pick a tool. Several of them picked a tool that didn't work. They were trying to come up with the answer, to come up with the sum of 7 or equivalent name for 11. It wasn't working. They were able to pick a different tool. Students that I was working with need a little bit more support in that area, but they persevered until they kept going and they were able to come up with those equivalent names.
And then like core action indicator A, which is giving explanations or giving representations. Like to start off the equivalent names, and we put up Mrs. Falk's picture up on the board, so students knew that she has got other names besides just what we call her Mrs. Falk. So the kids saw that in the real world setting then we took it into the number model, and we said, now let's use actual number, let's actually use manipulatives. Then they used a pan balance to go, okay, so an equivalent name is a number on both sides is going to mean the same thing. And they actually got to see it and represent it then, that if I put in 3 add 4, that's going to be the same side on this, which has 7 then. And we use the pan balance then to represent the abstract then, which is when they see that, oh, the equivalent sign, which is the equation mark. It doesn't matter which side the number goes on, as long as it's even on both, or the same on both names then.
I draw a blank.
I draw a blank on that too.
More coffee.
Yeah.
Oh. Check for understanding throughout the lesson using
Oh.
informal. We talked about that though. We talked about.
On core action 2 indicator B then, the teacher has to pose higher questions to the students and were they thinking about the content of the lesson and developing to the lesson. And that's one thing we did when we started looking at the core and we actually looked at our program was, are there questions embedded into the actual lessons then that are actually making them use the higher level thinking skills? And that's one thing that we noticed was that it was a lot of just recall and fact and memorizing. But we want them to extend their thinking then too. So when we asked the question then, what is the purpose of the pan balance? And students had to think of that and going, oh, well the pan balance is part of the equation. And as long as the numbers is balanced on both sides, I'm going to get the same answer. An equivalent name is the exact same thing. 3 add 4 is equivalent, which is going to balance because it means 7. So that means the equation has to be equal on both sides then.
Get them all. Uses variation in students. We talked about that. Checks for understanding. Took that. Guide student
Feedback
thinking.
time. Student
Feedback.
provides time for students' work with practice grade level. So think time is increased.
Think time.
You mentioned that one.
Yeah.
The core action 2 indicator C.
Okay. So core action 3 we need to look at. That was core action 2.
Core action 3. Oh, I love core action 3. So
We talked about those though.
yeah, we
talked
did
about
talk
tools.
about those.
Establishes classroom culture in which students explain their thinking. Did we talk about that? Well, we did. They talk about their strategies. I'm arguing with you on tape.
No, it's okay. We did core action A, which is student
Yeah.
uses the strategies then.
But did we talk about it? Informal language to precise mathematical language. You want to talk about that?
Sure.
Go ahead.
Okay, so another one we use too is core action 3, indicator D, where we're using the appropriate language. And one thing we truly believe in is using the accurate vernacular with the students and with the mathematics. And as we did today, we use the word equivalent name though, but we give them the connection to what the vocabulary means. An equivalent name is, you know, different numbers when composed together mean the same number then. So 3 add 4, and we had some kids who were doing, 2 add numbers together. And that was horrible. I need to redo that again. Sorry.
Well, looking at the language of mathematics, one of our students that I was talking to said, my answer is 5 plus 2. And I said, well, that's what you're showing me. What is the math name for that symbol? 5, and she didn't know it. So we went back to check with your partner. Did your partner understand? Well, it's 5 add 2, because we're putting two things together, that's addition. That came from the students. So we really, when they say 5 plus 2, we correct them, 5 add 2. But we're at the point now where they can choose that symbol and use it correctly. We don't say equals, what don't we say? I lost it. We don't say plus, I already got that one. So glad there's editing.
I just want to start this
Vocabulary,
conversation
vocabulary.
again.
I know, my gosh, that
We
does
do it
look
again?
terrible. Just go.
Do you mind if we do it again? Okay. So one thing we like to use is the core action 3 indicator D, which is using the precise mathematical language. And one thing we truly believe in is using the vernacular of the vocabulary with students in. And as you saw in the video today, we used equivalent names. We actually used the word equivalent, but we made sure that through the lesson, the students were able to connect to what the word meant. So we put a picture of Mrs. Falk up here today. And so the kids actually got to see she had multiple names in it. What did that mean? It means different names that mean the same thing. And so with the indicator, core action 3, we're using all the correct terms with them. So we had kids today who said, when they saw numbers that 6 add 4 and they turned around and said 4 add 6, kids knew that was going to be the associative property then. And we've done that since the beginning of the school year, is that when we introduce vocabulary to them, we connect it to their learning. So that way when they're talking to us later then, or using the vocabulary, we can actually say, well, what does that mean? Then they give us an example of what the vocabulary would look like then.
And I had an opportunity to work with a student who's newer to our classroom. And so she said, my answer was 5 plus 2. So I asked her, well, is that the math? What's the math name for that symbol? And she said she didn't know. So I had her check with her partner, and her partner said, well, it's add. So she said 5 add 2. So while they can plus and minus things, we're very consistent with saying add and subtract.
And then core action 3 indicator E, where the students get to use their own appropriate tools. That's one thing that's changed in our classroom quite a bit too, is that, before we'd actually give them the materials that we thought were appropriate for their learning then. We'd say, today you're going to use base 10 blocks or unifix cubes or rec and recs or number lines. But what we did is that once we showed the kids how to use the tools and they were learning from them, we're at the point where it's like, you need to choose the tools that are appropriate for your own learning. Because again, it is their learning that they have to do, and it's their opportunities. They have to make the connections for us. The only thing that we can do is ask the questions and provide the activities. And we've learned then too, by providing them with multiple tools then, they go to one that they're familiar with, and then they start using other tools to make more connections and then to build more strategies with.
And that doesn't happen right away. You have to introduce the tools one at a time. They're first graders. They have to explore with it a little bit, give them some opportunity, some guided practice with it before you introduce the next tool. So it took us some time to get through to where they had unifix cubes and rec and recs, number grids, number lines, and base 10 blocks. So we have to introduce those slowly. But once we've given them all the tools, immediately when they had 2 tools, they decided which one they could use. So even though they only had 2 to choose from, they still chose.
And then one thing we've learned then too is that not every tool will solve every problem. And so we noticed in our room today, this tool is not solving the problem. So what could you do? And we didn't tell them what tool to use, but they just naturally said, well, I'm going to use a different manipulative or a different tool then to help problem solve the lesson then. And then we came back to them and said, well, did it solve it this time? And they'd come back and explain it to us, say, yeah, if I use the rec and rec, or if I use the number line, I actually got to see and attend to precision and see the correct answer on there.
There were several times at my table working with a small group, one of the students she wanted to use the number grid, but she couldn't explain her thinking using the number grid. She could hop on it and get to 11, but she couldn't explain what she was thinking. So I did suggest a different tool to her, and she went to unifix cubes, and that worked much better for her. So there are times we have to intervene and say, that tool's not working for you. You have to be able to explain your thinking to me. Why don't you try something else?
And then one indicator we use quite a bit too, which is core action 3 indicator F, which is where we have students explain and justify their work. And that's been the heart of all of our math lessons, is that we have students justifying, explaining all of their answers and all of their understanding. And that's one thing that's changed in the Common Core, is that we're not spending our time doing 10 or 11, 12, and 13 problems. We're spending our time going into 2 or 3, but going deep within the lesson, so students truly have an understanding of what they're doing, but they can explain their thinking not only to us then, but to each other, and they use that knowledge from each other then to build their understanding relationships. And what's great then is because when we extend our lesson into the next units then, or into further study, they have that understanding that they built amongst each other because we've gone in depth into just those couple units then, or just in those couple problems.
And they actually have, and for their homework, they're given one math problem. They have to read it, with support sometimes. Then they represent it after they've taken some concrete manipulatives at home. We've given instruction to our families to have some Cheerios or buttons, anything that they can count at home so that they can actually physically move the materials. They represent it, and then they have to, at this point in the year, they're actually writing how they solved it. And we get comments frequently from the parents, I cannot believe how they were able to say, first I did this, then I did this, and this is how I know it's right. And they write it out for us. That's never something we would ever have expected in first grade. But we raised the expectation and they met it.
And then for the feedback of that core action indicator too, we actually use the students' feedback to help deepen the understanding of the others then. So when a student gives an answer that either has a misconception or the answer is wrong, we ask the rest of the class, and well, do you agree or do you respectfully disagree with that answer? And then we open it up to the class and, well, why is it you agree? Or why is it you respectfully disagree? Because if I just give my opinion, my answer to the students then They may not understand my reasoning and thinking, that, but at their level as 6-year-olds, when they're talking and justifying their answers to each other, they just unravel those misconceptions and they're actually going, they're showing and working with the problem and saying, well, this is my misconception, but here's why I think it's wrong. And usually with 6-year-olds, when they open up that discussion to them, they're able to figure out their own problems then. And through the feedback, which is through themselves in, they're able to reconstruct their misconceptions into correct thinking then.
All right.
Did we cover anything? What else?
So, think you need to ask him anything else?
You know, actually, the one question I do like to ask is,
Yeah.
reflecting on the lesson, what worked particularly well, and what might you do differently?
I got to think now. I got to reflect on the
Okay.
lesson now.
Yeah.
I got to get my notes too.
Okay.
Sorry.
I am ready.
What-
Get back over here.
Yeah, while you're getting your notes,
Okay.
did you guys have student work for this? Did they actually write anything?
They did.
on it?
They
Okay.
did. They were working in the student journals, and that's where I made notes.
You want copies of those?
Yeah, I'd like to take a couple photos,
Okay,
maybe
okay,
3 or 4 of
okay.
them before I leave. That'd
can
be
do that.
helpful.
Okay.
All right.
Okay. In reflecting back on the lesson, one thing that I know that I would like is pan balances that actually work. So, all kidding aside, I think it would have been nice to have more materials for the pan balances for the students to explore that in small group so they could take things and understand if I put this many objects, I can put 4 erasers in this and 4 Unifix cubes and it doesn't balance. Why is that? So there's some more discovery of that before we go to here's a pan balance and why does this work? So that would be an adjustment I would make.
Our goal then too, one thing I'd like to see extending the lesson too is that students are using more than just 2 digits then with equivalent names. That has to be a foundational piece for this lesson. And if we had more time with them, then we would extend and say, well, who's got a number model expression that has 3 digits? Or who's got one that has 4? And near the end of the lesson, and as I was walking around, then students were coming up with those. And I would have loved to have had them come up and share those answers and then have students in reasoning and problem solving. Why are those also equivalent names then? And we got to see those more on paper and pencil than we did on the oral side. But it was great though, but when they were actually representing, or if I asked them, well, how do you know that works? They took their cubes or they took their number grid and they were able to show me through the reasoning of how they're able to work with those 3 digits then to compose and decompose into the equivalent names then.
All right.
So what went well?
Were there any surprises? The table behind me was a huge surprise. Surprises. One of the students I was working with who was struggling with just 2 numbers, as finding it two numbers that equaled 11, came up with 2 add 2 add 2. How many 2s? 2 add 2 add 2 add 2 add 1, something like that. But she was able to break it into smaller pieces, and that was a surprise for me. And it made me realize that she has a very clear concept of 2 and 1. But when we look at numbers 3, 4, 5, she doesn't have as clear concept with that. So that's a student who needs to work more with some manipulatives and work around that concept of 3 and 4 and 5 so that she can add those larger numbers. But when she was able to break it into those smaller pieces, she was successful.
I wouldn't know if I called it a surprise, but it was something we expected though, was that students who went straight to the abstract had difficulties trying to write equivalent names then. And that's one thing I was looking for as I was walking around and checking their work then was, who are the students going straight to the abstract versus those who went to the manipulatives? Because any student who had the concrete manipulatives out were able to do it every single time. But the students who went straight to the abstract, they were struggling with it. But then they realized, when I told them, get your blocks back out and show me what that looks like, then they were able to do it every single time. And that's one thing I was looking for as I was walking around. And I was expecting to see that. And those are the kids I did see going straight to the abstract. Those are the ones who just needed redirecting. Go back to the concrete, go back to the conceptual, so that way you're building the understanding when you get to the abstract.
All right. Looks like you guys covered quite a bit. That's a good interview.
Okay.
Thank you.
Yeah. That's it.
Edit away.
Well, thank you.